Hello my friends, welcome to this tutorial of mastering TypeScript in Next.js. I'm JordanCarlzen, full stack developer at Hub. Welcome to my YouTube channel of modern web development with React and Next.js, where I'm going to be interacting with you on how to build and learn scalable SEO-friendly web apps from scratch. So subscribe to my channel, follow up for content about modern web development. This video, I'm going to understand what TypeScript is, how we can incorporate it in our projects, and very many more. So let's get started with TypeScript. So in this video, we are going to simply go through the basic syntax of TypeScript. We are going to understand the code, and by the end of it all, we shall be able to illustrate the code examples in a simple project. So Next.js framework, we are expected of using a few technologies such as Tailwind CSS and TypeScript. So today I'm going to talk about TypeScript. So TypeScript, it's not a mandate to use it. You can still use JavaScript, the vanilla JavaScript, but use these modern tools because of a few reasons. They saw it wise to come up with them. So it's upon us to adjust them such that we can apply them in our projects to increase productivity and efficiency of our work. So that's why we go on and run. So we can still use the vanilla JavaScript. So TypeScript is a superset of JavaScript that adds optional static typing. This simply means defining data types of variables, functions, and other constructors. This leads to improved code clarity, maintainability, catching errors early. That's all. So for TypeScript was discovered by Microsoft, mainly to improve scalability. It came with additional features like static typing, interfaces, and better tooling support. It compiles to JavaScript for the browser compatibility. So the analog of how I can illustrate this. So let's look at JavaScript. As a kid who is messy, who just throws his tools anyhow in his toolbox, for TypeScript, let's look at it as a kid who is organized, who stores his tools in a toolbox. Like you see, this kid has a section for cars, a section where he keeps the dolls, and the tools you use in a more organized way. So comparing these two kids, this kid can easily locate his tools, can easily pick out this small doll because he simply stored it. He can easily access it, unlike this kid who can't easily locate where his doll is, where his tool. So that's the whole picture of JavaScript. It's a bit messy. It's hardly to locate our tools. So fellow developers who have been using JavaScript for a long time, it's high time you crossed over to TypeScript to be this organized kid who can easily locate his tools whenever he wants. With that said, let's get into the best benefits of TypeScript in Next.js. So we talked about static type checking that helps us to catch errors, improves code maintainability, enhances development experience, supports large-scale applications, seamless integration with React and Next.js. So why TypeScript? Has deep TypeScript support, growing demand for TypeScript safe applications, enhanced development experience, better debugging and factory tools. So without wasting any time, let's go into installation of TypeScript in a Next.js project, and we see how we can apply it in our project. So I'm going to start with creating a folder and naming it TypeScript. TypeScript beginner project. Open it with VS Code. In VS right now, so I'm going to open a new terminal. So the command is pnpm create next app in this very directory. So press. So they will ask me whether I would like to use script. I will go on and say yes. So in case yours is that no, you can simply move the arrow to yes. So I'll press enter. So they will ask me whether I would like to use ESLint. I'll say yes. So ESLint specifically enables us it shows us the errors that we make. So it doesn't allow us to proceed with our errors. So it will ask us to whether to use Tailwind CSS. We also go on and say yes. Shall I use the app folder? For the app route, we say yes. Double pack, say yes. Say yes. So it will go on and install all the necessary dependencies and packages. Sometime. So having installed everything successfully, I have my environment set. So I have this app folder where I have the page.tsx. You can see that the extension is tsx now. So this is the app folder where I'm going to be working. So when I go to the browser, I run pnpm dev. So this command will generate me the host link. So when I tap on it, it will definitely take me to the home page of my application. So when I go back to the VS Code, I can delete all this, Control A, then delete. So when I type RFC, React Functional Component, I press enter. So it's still bring me this page. You can go on and name it home page. Home. Sorry, the naming here. Home. I can write an H1 here and say welcome to TypeScript. I can put some styling. Can give it a text of Excel. Can center it. So give it some padding. So I'll give this padding like 2 rem. So that is 8. And let's go and see how it looks like. Yeah, so this is it. Welcome to TypeScript. So we have our environment set and we are set to start. So let's look at TypeScript inference. So this simply means that you can define types of the variables you use. The rest of that we can come inside our function before the return. Now this return returns the HTML markup. So whenever you want to write some TypeScript, you can do it here before the return. You can also do it inside the return, where you can write it in these curly brackets. But we are going to be doing that outside the other return. So let's start. We're going to start with simple basic syntax. So let's start with this. I'm going to let name equal to JordanCarlzen. So this is the usual JavaScript. you have this string you're assigning to this name. So TypeScript, you can still do the same thing in TypeScript, but script is like you hear TypeScript, you're assigning types to your variables, your functions, and very functions, constructors, and very many more. So TypeScript simply looks like this: name. So after saying that this is name, you go on and define it. That name is going to be a string. Defining what it is, you can go on and assign something to it. JordanCarlzen. Comment this. So this is defining the name of the variable, the type of the variable. Then after, you assign something to it. You can also first declare it, then assign something to it. So our data types, we have the primitive data types. We have the number. So let me say the price, and define it as a number. So I assign like $300 to it. So that's it. I can also have a boolean. So let me say as paid. Then I define it as a boolean and assign a value to it. Let me say true. So these are the data types we have, the primitive data types, the number and string. So this is simply how we define types of our variables in TypeScript. You can write it like this, but still, even if you don't attach these types to your code, TypeScript is wise enough to detect that this is a string. So to illustrate that, I can come here and say that name is equal to 4. So like you see, the error telling me that type number is not assignable to type string. So TypeScript already knows that this name is of type string. So when I come here and assign a number to it, they will tell me that this can't be possible since I already defined my name as a string. So in JavaScript, you can go about this without having any problem. But for TypeScript, strictly, you have to follow the rules that the type you defined above is of so and so. So that's the static type checking. It's always checking and referring to what you did above. So this is simply called TypeScript inference. TypeScript will go on and refer to and infer to the type you assigned initially. So when you go here and change it to a string and you say like sum, it will work. So having understood that, let's proceed to more advanced data types. So let's talk about arrays. Someone may ask how do we define the arrays? So the arrays, we simply define them. Let me say I have an array of strings. So I will simply come here and say that const array. I can come here and say it's going to be a string array. So we write it like this: string array B that will contain strings. Let me say TypeScript. Let's have JavaScript. Tailwind. So this is my array of strings. So we simply defined this variable, my array. We defined it as a string array. So having defined it as a string array, you can go on and assign these strings to this variable you are assigning it. So this is simply how we define types of an array. So you can also have an array of numbers. Say const my array of numbers. We define it as a array of numbers. So inside here, you can only pass in numbers like that. So if you want to see how the inference works, you can go here and add something like a figure. Let's say 200. So there will be this error that type number is not assignable to string. So TypeScript will have detected that you have added something that you didn't define to in your array. So this is the benefit, one of the benefits of using TypeScript. It checks for you before even you proceed to other work. It shows you an error or where you are messing up things from. So this is how we simply define arrays. Let's jump to tuples. So these are the tuples. So tuples are also simply arrays, but more advanced. So these are fixed length arrays with specific element types at each position. So to illustrate this, I can say const name it my array2, then inside here I can define the types. So I'm going to define them like this. So I can say in the second position I'll have a number. Then in the third position I have so you go on and assign. So in the first position we said we have a string. So TypeScript is expecting a string at index 0. So you go on and say type a string TypeScript. Then in the second position they expect a number. So you put a number, and in third position they expect a book, which is true or false value. So you write it. What's the error? So they're telling us array element destructuring pattern expected. Left side of the comma operator is unused and has no side effects. Left side of the comma operator is unused. So you always have to read what they are telling you. So I think the error is at this point. So it was supposed to be an equal sign. So this is a tuple. So like you see, I said in the first position I'll have a string. So it's the string I have, number in the second position, and boolean in the third position. So in case I come in the first position and put like a number, TypeScript will tell me type number is not assignable to type string. Since I already defined as the first position will be a string, so TypeScript is already expecting a string in that position. So when I use some other type that I didn't define as my first position, TypeScript will show me, will bring that error telling me that that's not what I defined. So that's the tuples. So you can have your data arranged in such a way. So if you wanted to have a mixture of data types in your array, this is simply how you do it. Let's go to functions. For functions, they're simply defined using function keywords, specifying input and output types. Then you have what you call type annotation. This is simply defining the parameter, the type of the parameter you are passing in the function. So Like you see, as we've done all this, it doesn't have a big difference with normal JavaScript we've been dealing with. Here we are simply assigning types to all our variables, arrays, the function like we're going to see. So like you hear type, simply type, defining types of the things we will normally use in the usual JavaScript. So we go to functions. So let me say function, we call it login. That's the name of our function. So it's going to take in the password, parameter password, which is going to be a string. So I'm simply defining the type of the parameter that I'm going to take in my function login. So I can come here and console log the password. So that's it. That's how we can define a type of a parameter that we are passing in our function. So before you proceed to the next step, you can also define this function is going to return. So you can say that this function is going to return a string. So you expected to return a string after running this function. So I can come out here and say return. So I can return the password. So since I defined password as a string and I'm a string, so simply means that I've made good use of what I defined initially. So for functions that return void, you simply write them like this. Let me say sign up. Sign up. So this is the function sign up that takes in username. We define username, the string. Then we can define that this function is going to return void. It's not going to return anything. So TypeScript will be expecting this function not return anything. So that's how we simply define the types of the parameters in our functions